In this video, I would like to show a simulation development where we perform the simulation of BLDC motor by using MATLAB simulating software. The complete simulation of BLDC motor can help to make an analysis based on the speed, duty ratio, the current, and also the voltage. So for the first step, we decide the BLDC motor parameter. So then, after we decide the BLDC motor parameter, we run the parameter to ensure the BLDC motor in the next simulink had the parameter that we run. This simulink shows the BLDC motor, simulink BLDC motor design with load torque. So in this design, we had BLDC motor. The BLDC motor, we had back EMF. So there is phase A, phase B, and also phase C. So there is also a sin theta. Then we had inverter. So in the inverter, we decide the input voltage, which is VDC, equals to 24 volt. So we had three-phase inverter. Then we had gates. This is the step in design. And then we had Hall effect sensor, where there's back EMF, and also we have this is the switching. This is the Hall effect sensors Hall switching. So next, for adjusting the load torque value, we click the load torque block. So we adjust the final value from 0, 1, 2, and 3. So for 0 value, we apply. Then we run the system for 5 seconds. After run, so we the value of speed on the speed oscilloscope. We click speed oscilloscope, and this is the value of speed, where when the top 0, the maximum value of the speed is 7084,000. Then we click the voltage scope. The voltage scope shows that the maximum voltage when the load 0 is 2.556 volt. For the current scope, so the maximum value is 1.1110 kilo. To see the difference between 0 and 3 Newton meter, so we adjust this again. Then we adjust the final value to 3 Newton meter. So we apply, and then we repeat the same step where we run the simulation. We see the speed scope, and it shows the maximum value of when the value of torque adjusted, the speed decreases to 5194,000. Then we check the voltage scope. The voltage also decreases, and for the current, the value is the same. So the next one is MATLAB simulating design of BLDC motor with duty ratio. So for this design, it has the same design as BLDC motor with load torque, where it has a same BLDC motor, the same switching, and also the same inverter. Just the step 5 duty ratio which is 0, 25%, 50%, 75%, and also 100%. So if the value is 0, so the final value would be 0. If the duty ratio is 100%, we write it as 1. So for the first step, we would see when the duty ratio is 25%, so we apply. Then it has the same stop time. Then we run the simulation. We click the speed scope to see the value of the speed. Of the speed shows the value is 1088 kilo RPM, 1088,000 RPM, revolution per meter. If we click the voltage scope, it shows that the maximum value of the voltage is 4 volt. For the current scope, it shows current is 1.262 kilo. Then we adjust the duty ratio, okay, to see the difference of the speed to final value 1, as it is duty ratio equals to 100%. Then we apply. Then we run. Okay, after the simulation completely run, click the speed scope. So it shows the value of the speed is 4,088,000 RPM. The voltage increases to 8. The voltage we click the. So after completely run, we click the speed scope. So the scope with the value of speed, it shows 4,472. Then for the scope, next is the current scope. For the hardware development, first we prepare all of the prototype that needed for the hardware development. So there is a controller circuit, where in the controller circuit we have a duty cycle controller and also a frequency controller. Then we have a gate driver circuit. For the next one, we have a 3-phase inverter prototype. And also we have a BLDC motor prototype. So then we assemble all of the prototype. We have a 3-phase inverter prototype. Then at the below one we had a gate driver circuit, and the upper one is the 3-phase the controller. Then we connect it to the BLDC motor. So there is the positive and the ground. Positive one is the red one, and the ground is the black. Then we have the phase A, phase B, and also phase C. Then we connect it to the oscilloscope and also the power supply. So we connect the probe to the prototype, as we want to read the current and also the voltage of the prototype. So we connect it to the between the 3-phase inverter and also gate driver circuit. Then we push the start button. We increase the current value, and we also increase the voltage of the BLDC motor gradually, as we don't want the load, as we don't want the voltage to over the limit of the BLDC motor. So after we increase the voltage and the current, we can see the waveform of the current and also the voltage of the prototype. we connect it with 4 probe. So for probe phase A, phase B and phase C, we connect it to this wire where it connected to the phase of the motor. Then we take the reading of the BLDC motor. So we take the reading of frequency and also the reading of the current of the BLDC motor. So we adjust the frequency and also the duty cycle, and the waveform of the BLDC motor will appear on oscilloscope.